Okay, hopefully this microphone actually is working. So let's go through this. Notice it says what not to do. So try not to write every single thing. Just try to do the things that you really didn't remember. Okay, matter. It's defined as anything that has mass and takes up space. So everything is matter outside of outer space where there's the absence of matter. It can be classified as elements, compounds, mixtures, and we're going to go over those. It's all made up of atoms, and the four phases can be solids, liquids, gases, and plasma. Remember that plasma means charged particles. They're ions. Okay, so if it talks about the nucleus being broken apart and electrons being released, or radiation, or charged atoms, it's talking about plasma. Your examples would be the auroras, or the northern and southern lights. Also, lightning, the sun, all stars are made of plasma. Okay, atoms are defined as the building blocks of matter. They are always moving. Even in a solid, when they're very close together, they're still moving. Atoms of the same element are alike, which means, I know it's hard to see, but this says hydrogen. All hydrogen atoms would look like this. All helium atoms would look like this. This is lithium. Electrons are negative, and they're very small. They're 0.0006 AMUs, which means atomic mass unit. It's just a measurement that we use to measure the parts of the atom because they're so small. Protons are positive, and they are 1 AMU. Neutrons are neutral, and they are 1 AMU. Electrons are found in the cloud. Protons and neutrons are found in the nucleus. Compounds are when two or more elements chemically combine. So it would be very difficult to separate them. You can separate them, but it's very difficult. Mixtures are physically combined and easily separated. All right, pH scale. If you look at it, 7's right in the middle. This is neutral. The farther away from 7 you are, the stronger you are. So 0 is the strongest acid, and 14 is the strongest base. Acids release the H plus ion, the hydrogen ion, and so if you look at all these acids, you see that H right in the front. Bases release the hydroxide ion, and if you look at all the bases, they all end in that OH. And what this does, this OH and this H, when they bond, so let's imagine they go through a chemical reaction, that's what this arrow means. Chemical reaction has taken place. You notice that water always ends up being created, and also a salt. So salt and water are created. This is called neutralization. So you took equal strength acid with an equally strong base, you mix them together in a chemical reaction, and you get salt and water. All right, the periodic table is an order of atomic numbers. That is the little number in the right-hand corner. They tell you how many protons there are. Let me do an example. All right, so if we had lithium, sorry, my box is horrible there. We'll put a 3 up here, lithium, and a 7, sorry. This little number is the atomic number, and it tells me how many protons there are. And then it says that electrons always equal protons, so it also tells me electrons. The atomic mass, which is this bigger number, tells me protons plus neutrons. So if I take that number and I subtract my protons, which is 3, I get 4, which is how many neutrons I have. Okay? So if they ask you how many protons, neutrons, electrons, that's how you do it. The family can also be called a group, can also be called a column. These are vertical. They go this way. So there end up being 18 total if I went across. 1, 2, 3, 4, 5, 6, 7, 8. So if it asks you which column, you just literally count and see which one it's in. Rows and periods are horizontal, so they go like this, and there are only 7 of them. 1, 2, 3, 4, 5, 6, 7. These two actually go in here. They've just been pulled out for easy reference, but if you look at the numbers, they actually go in here. So they are rows 6 and 7. All right, so if we look again, just to remind you, 1, 2, and then you just keep counting, 3, 4, 5, 6, and you end up at 18. They're in a family because they act the same. They look the same. So all of these have a harsh reaction with water. Most of them are white and powdery except for hydrogen. Another thing that they have in common is that they have the same number of valence electrons, and that's how many electrons are in the outermost level. So they have 1, they have 2, 3, 4, 5, 6, 7, 8. Remember that magic number is 8. They're trying to get 8. That's the octet rule, O-C-T-E-T rule. And so families that have 7, like this family, will always bond with the ones that have 1 because they're trying to reach 8. And that's a type of ionic bonding. Oxygen family has 6. It always tries to bond with the alkaline earth metals because they have 2. The transition metals, all these right here, can have 1 or 2. They're never going to ask you those, okay, so don't worry about that. Just know 1, 2, go over to the boron family, 3, 4, 5, 6, 7, 8. Because these guys are full, they have 8, they can never bond with anybody. Remember, these are the noble gases. All right, the staircase that's on the periodic table separates your metals and nonmetals. You're going to see a picture in a second. The metals are on the left and the nonmetals are on the right. Elements that touch the staircase are called metalloids, and they have properties of both metals and nonmetals. When atoms lose electrons, okay, this is ionic bonding here. I'm just going to put ionic. When they lose electrons, they're giving them away. It is considered positive, so they become positively charged. Think of somebody who is giving. It's a positive trait. When they gain or they take electrons, it is a negative. Think of it as a negative trait. You're just taking all the time. You're not giving. Okay, so if they lose, they become positive. If they gain, they become negative. Down here again, it says how many valence electrons do the noble gases have, and the number is 8. They are full. Metals can be ductile or malleable, which means they can be bent into wires and hammered into thin sheets. They conduct heat and electricity, meaning they let it go through, and they're shiny. Nonmetals are exact opposite. They're brittle. They break. They do not allow heat or electricity to go through, and they're dull. So if you look up here, here's your staircase. These are your metalloids. All of these over here are your nonmetals. Everything else is a metal. Notice that hydrogen is not a metal, and that's because it's a gas. Okay, so if they ask you about hydrogen, it is the only one on this side that is also a nonmetal. All right, bonding. Covalent means that they share valence electrons. Co always means share. A co-worker shares the work with you. Okay, and valent means valence, the outermost electrons. So they share the outermost electrons. Ionic is when they transfer. They give away or they receive electrons, and then they become charged, which is what an ion is. They become charged positively or negatively. It says that the element has 8 valence electrons. It cannot bond with another element. We already talked about that. Poly always means more than one. So this means more than one atom or type of atomic bonding. Water is an example of this. It has both ionic and covalent bonding. So what kind of bonding would this be? What we see here is that this atom is giving away this outermost electron of 1, which then gets rid of that level, and then they have a full outer shell of 8. They give it to this one that only has 7, so then now they have a full outer level of 8. So because this one gives away 1, it becomes positive by 1. This one receives 1 and becomes negative by 1. Okay, balance and equations. Let's first just look at N2O4. And let's imagine it looks like this. You could visually see it. I have my 2 red nitrogen and I have my 4 oxygen. Okay, and imagine I gave you a baggie that had those in it. This 2 means I have 2 baggies of that inside it. So if they ask you how many atoms, if you need to draw out the picture, do that. So if they were to say how many nitrogen atoms do you have, I would say I have 1, 2, 3, 4. How many oxygen? I have 4 here and 4 here, so I have 8. If they ask me how many atoms total, I'm going to count all of the marbles, and that's how many I have. The law of conservation of anything means that what goes in must come out. Nothing can be lost, nothing can be destroyed. Reactants are always on the left. So in this one, the reactants would be H2 and O2. The arrow always points to the product. So in this example, the product is H2O. If this were switched and it said H2O yields or produces, that's what this arrow means, and then it said H2 plus O2, my product would be whatever is on this side of the arrow. My reactants is whatever's on this side of the arrow. Mixture types. Homogeneous, remember HOMO means the same. So a homogeneous mixture looks the same throughout. If I look at this milk, I cannot tell that more than one thing are in there. It's mixed well. Heterogeneous, Hetero, means different. So if I look at this mixture, I can see lots of different things are in this mixture. It is the least mixed. A solution is best mixed. Something has been dissolved. If I add sugar to my coffee, it's been dissolved. It is a mixture. I can get the sugar back out. All I have to do is boil out the water out of the coffee, and then eventually the coffee grinds, whatever made up the coffee flavor, and the sugar would be left in the pan. But because something has been dissolved, it is best mixed, and it's called a solution. Remember, the solvent does the dissolving. The solute is what's being dissolved. A colloid is always cloudy. Milk would be a colloid. Fog, smoke, paint, toothpaste. If they use the word cloudy, they're talking about a colloid. All right, fission versus fusion. Fission is splitting of the nucleus. It produces lots of radioactive waste. An example would be a power plant. Fusion is what the sun does, so much more powerful. It is the fusing of, the joining of 2 nuclei, and it's very little waste. These are your types of radiation. An alpha particle is actually a helium atom. It is the weakest form. Remember, it can be stopped by paper, causes the skin to turn red. The beta is 10 times stronger and has to be stopped by lead. It is an electron. Remember, Einstein said the smaller something is, the more powerful it is. The gamma ray isn't a particle at all. It's just a wave of energy, and it is the strongest and needs to be stopped by several centimeters of cement. Exothermic versus endothermic. Exo means exiting, leaving. Thermic means heat. So leaving heat, it's releasing the heat, and it produces something that is hot. Think of the experiment we did where when you mix the metals with the acid, immediately it boiled. Endothermic is where heat is being absorbed. It's going into, and it becomes cold, like an ice pack that you might get. You start the chemical reaction, it becomes cold just for a little while. Chemical reactions produce new substances with new properties. Okay, so the old properties are lost. Burning, cooking, rusting, those are chemical reactions. Physical reactions allow you to get the same thing back. Melting something, freezing something, ripping something. It is not changed into a new substance. Energy can never be destroyed nor created, so it just converts from one to another. Energy is the ability to do work. That's its definition. You have 2 main categories, kinetic and potential. Kinetic means moving. Potential means stored or position. If I have a stretched rubber band, it's in the position that when I let it go, it will become kinetic. Sound is mechanical energy. Mechanical is an example of kinetic energy. That means it moves. Energy sources. Photo means light, so this uses light to create electricity. A battery uses chemicals. A wind turbine uses movement. A thermocouple uses heat. Okay, so these are different ways that we can get electricity. Heat is created through friction. If you rub your hands together, the more movement, more heat. No heat is added during a phase change. So if something is melting and something is freezing, they both occur at the same temperature. All that's changing is that the atoms are either speeding up or slowing down, but the temperature does not change during a phase change. Absolute zero is a theory that says this is what would occur if all the atoms stopped moving. But atoms never stop moving, so it's never existed. If it did, they would call it 0 Kelvin or negative 273 Celsius. Heat transfer is how heat is transferred from one thing to another, and there are 3 ways. Conduction is direct contact. I cannot cook anything just by holding it over the heat source. It has to touch the pan. Convection would be heat rising and falling, making these circular convection currents. This is what causes weather in the atmosphere. You might have seen noodles being cooked in water and they move up and down in these little convection currents. It's the reason your upstairs is warmer than your downstairs. Radiation is heat traveling through empty space. It's how we feel the heat from the sun. It's also what happens if you sit close to a fire. You don't have to be above the fire to feel the heat. You just need to be close. Sound is produced through vibrations. So the first vibration would be the vocal cords. Then it vibrates the air, and then it vibrates the little bones in the ear. Eventually you hear it. It travels as a compressional or longitudinal wave. It is fastest in solids because all the atoms are very close together and it travels through quickly. The farther apart the atoms are, the slower it goes. The example I gave you in class would be that an Indian might put his ear down to the ground to hear a stampede before it gets there. A reflection of sound must hit a flat surface and it is exactly returned. It's what we call an echo. Sound is used in ultrasounds. In fact, it's very useful. You can actually see what the baby looks like now, way better than it used to be. Sonar devices use it to map where big school of fish are or what the ocean floor looks like, and so it sends a sound wave down, it bounces back when it hits the surface, and they can figure out depths of areas that we can't see. Frequency is how fast or slow a wave is moving. High frequency equals high pitch. Think of a really high pitched voice. Girls usually have a high pitched voice. Low frequency would be a low pitch. Intensity is talking about the strength of the sound wave, also known as how loud it is. Light, I'm sorry you can't see up there, light can be absorbed, reflected, or transmitted, which means goes through. It changes when it hits different mediums. Light slows down when it hits liquid. Remember, we had the pencil or the straw in the water and it looks bent. This is because it slows down when it enters the water. It is an electromagnetic wave. It's absorbed by black objects, so no light is reflected and we see black. It is completely reflected by white objects, so all the colors are reflected and we see white. Whatever color you see when you look at something is the part of the Roy G. Biv light spectrum that is being absorbed. Transparent means see-through, translucent means foggy but you can see through, and opaque means you cannot see through it. The electromagnetic spectrum. The radio waves are the weakest. Look how big the wave is. It's a big wave, it's going very slow, and over here by the gamma ray, they're very tiny waves and they're moving fast. Again, remember, the smaller it is, the more power it has. Visible light is the only one we can see. I'm reminding you of that Roy G. Biv, which you can see right here, your red, orange, yellow, green, blue, indigo, violet. If they ask you on the color spectrum which is the more powerful or has the highest frequency, it's going to be the violet because it's closer to the gamma side. Alright, force and motion. Force is a push or a pull. It's measured in newtons. It can cause something to move, something to stop, or change direction. The net force is what's actually acting on a moving object. Remember the tug of war scenario, and if one person is winning, however much more force they're doing is what's acting on the rope, and it moves in their direction. Speed is distance divided by time. Velocity is still speed, you just add direction. It's still distance divided by time, but you just say it's north, south, east, or west. Weight is the pull of gravity. Weight and gravity always go together. If you went to the moon, your weight would change, but your mass would not. You did not get smaller, just gravity is less, so you weigh less. The speed of gravity is 9.8 meters per second every second. It pulls on every object exactly the same. It might give you a scenario. In a vacuum, what would happen? In a vacuum, everything falls exactly the same rate. A feather would fall at the same rate as a big rock because there would be no air to slow down the feather. The first law, inertia, means something moving wants to stay moving, or something still wants to stay still. Think about trying to get a stalled car moving. It takes a while to get it moving, and once it is moving, you wouldn't dare run in front and try to stop it, because now that it's moving, it wants to stay moving. The second law deals with how much mass or acceleration is needed for a certain amount of force. Your third law is about your actions and opposite reactions. If something pushes forward, it gets the same amount pushed backward. A rocket taking off moves up with the same force and intensity it's pushing down. Newton's law of gravity says that anything that has mass has gravity, and the bigger the mass, the bigger the gravity. Jupiter is the biggest planet, so it has the highest gravity. A machine is any device that we use to make work easier. Resistance works against. Work input is always more than work output because the machine causes some friction which slows it down. These are your 6 simple machines. Remember, wedges are sharp, pulleys change direction, inclined plane is like your ramps. You know what a screw is. You can make a screw better by adding more tread to it. You have your 3 levers, remember, on your arm. First class is your elbow, second class is your wrist, third class is your shoulder. Electricity. Resistance, which is measured in ohms, is lowest when the wire is cold. That means all the atoms inside the wire have gotten out of the way, they've bunched together, and now the electricity can flow through easily. Current is measured in amps. A series circuit only has one path, so if one thing goes out, the whole thing goes out. This is your old Christmas lights. A parallel circuit has multiple paths, so if one goes out, the whole thing doesn't go out. Static electricity is the buildup of electricity, and then it's discharged when it touches something else. Electromagnets are strongest when you wrap the wire around more times. All right, if we look at this simple circuit, your load is what's using the electricity, your source is what's creating electricity. You have an indicator that tells you how much electricity is being used, and you have a switch. All right, good luck.